Okay, so we're in chapter 9, which is just comparing fractions. We learned what fractions are. They're pieces of wholes. And we learned, how to find values as a fraction with unit fractions. So comparing fractions, it's not going to be much different. It might be actually even a little bit easier since now we understand a little bit what fractions are. So we know the terms half is 2, thirds 3, fourth 4, sixth 8, and eighths. We know that. So I want everyone to go through this page right now and just see if they can go through it and get it done. The first page. The second page has our definitions, and the ones we're going to use are for the top part is the ones with the check mark. So this is saying 2/3 is greater than 1/3 because think about this. If you have 3 pieces of pizza, you have 2 pizzas that have 3 pieces. This one still has 2 left. This one has 1 left. We know this one's going to be more. We have more of this. So this would be greater than. Now this one, let's say we have a piece of cake that has 4 pieces. There's 1 left here and there's 2 left here. Which one has more? 2/4. So this is the less than sign. It says 1/4 is less than 2/4. You got to read it like a book. Now this one, 1/4 is the same as 2/4. Well, that don't look right, but it does. 1 is half of 2. 2 is half of 4. These are both considered halves. And we'll learn how to reduce this to make this look like 1/2. Okay? Even if it said this, 3/6. 3 is half of 6. If it said 5/10. 5 is half of 10. They all equal 1/2. So these, even though they're different numbers, they're actually the same. So these are equal to. The next one, we both have 1 as the numerator. We know those are unit fractions. Smallest unit. A unit is small, so that's what we're going to have to do. The next one, 2/2 and 4/2. These are going to make whole numbers. A fraction is part of a number. A whole number is 1, 2, 3. They're actually real numbers. This 2/2 equals 1 actually. And 4/2 actually equals 2 because 2 can go into 4 2 times. So these are actually 1 and 2. Those are whole numbers. This one says, what's 2 fractions that name the same amount? We know that those are actually called equivalent fractions. Equivalent fractions means they are equal. Equivalent, equal fractions. I am part of the fraction above the line. I tell how many parts are being counted. This is what's up here. It is the numerator right here. Numerators on top, denominators on the bottom. I'm the part of the fraction below the line. Below, D for down, that's the denominator. So make sure you get these vocabulary words on there, okay? You need to pause here, pause it now. And if you need to pause here, pause it now. And then we're going to keep going. These are your vocabulary words that you can practice. And we're going to go ahead and get started on comparing fractions. Remember, this chapter might be a little bit easier than the other ones. So we're looking at less than, greater than, and equal to. Make sure you understand these signs. Study them. If it's pointing left, it's less. If it's pointing right, it's greater than. Just think, left, less. That's how I always remember. Mary and Vincent climbed up a rock at the park. Mary climbed 3/4 of the way up the wall. Vincent climbed 3/8 of the way up the wall. Who climbed higher? Well, we can act out this problem by using manipulatives to help us solve our problem. Now, you guys don't have manipulatives at home, but we have them at school. And that's what we'll be using. So what do you need to find? Well, we need to find who climbed higher. Who climbed higher? We want to know if Mary climbed higher or Vincent. We know Mary climbed 3/4 and Vincent climbed 3/8. How will I use blank and blank the lengths of the models to find who climbed? How will I use 3/4 and 3/8? Or I will use you can say I will use manipulatives. It's up at the top. And measure. We're going to see which one's longer. The length of the model to find who climbed higher. And manipulatives are little blocks. And you have these little blocks that looks just like this. So what they decided to do here was they decided to use a whole number, as the wall. And whoever fills up this 1 or gets closer to the end of the 1 is actually who climbed higher. And this is what Mary did. 1/4 plus 1/4 plus 1/4. I'm going to put M right here for Mary. I'm going to put V right here for Vincent. This is 3/4. Look how far Mary went. And Vincent went 1/8, 2/8, 3/8. This is how far Vincent went. Well, if we're climbing up this big ladder or this wall to reach the finish line, who's closer to the finish line? Mary. But you say 8's bigger than 4, Mr. Heaver. How's that right? That's true. But think about this. They're all the same whole. Everybody is the same right here. So if you have more pieces, they're going to be smaller. Less pieces, they're going to be bigger because it takes less pieces to make the entire thing. If you're doing a puzzle, think about it like that. Let's say everyone in the class has a puzzle. It's the same design, the same shape, the same size. Someone's just 2 pieces. It's going to be really big pieces. Say someone has one that's 100 pieces. They're going to be small. Think about it like that. The more the pieces, the smaller it is. Think about it like a puzzle. The more puzzle pieces it takes to finish, the smaller those pieces are going to be. The less pieces, the ones you do as a kid that have 4 and 5, they're pretty big pieces, almost like blocks. So the numerators were the same, 3 and 3. That's cool. But the 8 has smaller pieces, so this 3 is going to be smaller. So I'm going to say 3/4 is greater than 3/8. The length of 3/4 model is bigger. So Mary climbed higher. So Mary climbed higher. If you need to pause right here, go ahead and pause. All right. Next page. Students at a day camp are decorating circles for placemats. Tracy finished 3/6 of her placemat. Kim finished 5/6 of her placemat. Who finished more of the placemat? What do we need to find? Who finished more of their placemat? It's this last sentence right here. Who finished more of their placemat? Now, what will we use? We know that Tracy finished 3/6, and Kim finished 5/6. Tracy finished 3/6 and Kim finished 5/6. That's our biggest information. How will I use this information? Well, we can use manipulatives, but you don't have them. Okay, you do not have manipulatives. So I do, but my document camera's not set up to show you. How will I use this information? We can, let's say, we will practice by drawing models. And this would change if we were here. It would change if we were here, but where we're not, we're going to draw it. Okay. We will practice by drawing models. So the cool thing about this one is we have 3/6 and 5/6. Think about this. 3/6 and 5/6. What do you notice are the same? If these are the same, if both, let's think of it as puzzles today. If both of our puzzles, if we have the same puzzle and they both have the same amount of pieces, this is where it changes. You have only completed 3 pieces of your puzzle, or Tracy's only finished 3 pieces of her puzzle, while Kim finished 5 out of 6 pieces. So really, 5 is now more because the denominators are the same. Because let's think of it like this. I'm going to draw a model, and this is going to be, I'm going to draw it in sixths. So we have 2, 3, 4, 5, and 6. Each of these stand for 1/6. I'm going to color in Tracy as red. So Tracy has done this, 2, and 3. And Kim, I'm going to color as, let's say, purple. Kim, where they have the same pieces, so we can use the same model. Kim did 1, 2, 3, 4, and 5. So really, we can look and we can say, wow, who did more? Obviously, Kim did more. So Kim did 5/6. So I'm going to say 5/6 is greater than 3/6. Now, there's one more way that we could do that, but you have to know your multiplications. I'll explain that in person then. So, how did your model help solve your problem? Or go ahead and, if you need to pause this right here, pause it, please, because I'm going to keep going. How did your model help solve the problem? It gave a visual, we could actually see it, representation. And representation means a model. It gave a visual representation. It presented that we know that Kim did go farther. So it gave a visual representation. It says Tracy and Kim each had a carton of milk at lunch. Tracy drank 5/8 of her milk. Kim drank 7/8 of her milk. Who drank more milk? Well, let's look at it. Tracy, I'm going to put a T for Tracy, is 5/8. Kim is 7/8. They have the same denominator, which means we're going to state what the top number. Who has the bigger top number? It's going to be Kim. Because again, if we have the same model, I'm divided into 8 pieces. So it's 2, 3, 4, 5, 6, 7, 8. And let's do the same thing. Let's do red for Tracy. 1, 2, 3, 4, 5. And let's do purple for Kim. 1, 2, 3, 4, 5, 6, 7. We can definitely see, if this is the same model, that Kim drank more. That's because they have the same denominator. Same denominator. So they're the same denominator. Kim's denominator is higher. Numerator is higher. So same denominator. We just go off the numerator. If you need to pause it right here, pause it. Go forward. At the park, people who climb a rope ladder to its top, Rosa climbed 2/8 of the way up the ladder. Justin climbed 2/6 of the way up the ladder. Who climbed higher on the rope? First, what are you asked to find? Well, we're asked to find who climbed higher. That's what we're asked to find. Who climbed higher? It's the last sentence. Now, we look at it. This is the same numerator, not the same denominator. And this is where it's a little bit harder. The same numerator. So we need to look at 2/8 and 2/6. Our denominator are different, but our numerator is the same. So what's going to happen is the pieces are going to be different sizes. Remember, more pieces equals less. So what's one of these has more pieces? 8 pieces or 6 pieces? You should say 8. So these pieces are actually going to be smaller than these pieces. You have 2 pieces for each, but this one is actually going to be less than. And I'll show you. So here we have 2 holes. I'm going to draw 2 blocks, and I'm going to represent 2/8 and 3/8. So here is 2/8 right here. 2/8. We have 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to shade in 2. Okay. Down here we have 2/6. So we have 2, 3, 4, 5, 6. Now I'm going to shade in 2 of this one. 1 and 2. Look how much bigger 2/6 is. Because 2/8, the pieces are smaller. We both have 2 pieces. That's fine, but your pieces are going to be smaller. So really, who climbed higher? It's whoever did 2/6, and that was Justin. So Justin climbed higher on the rope. The other way we can do this, so I'm going to go ahead and explain it now. It's called a butterfly method. Okay? You're going to use this now, and you're going to use this in the future. But you have to know your multiplications. We're going to draw a butterfly with these. And a hint, a butterfly flies up. So what we're going to do is we're going to circle the denominator on one side up to the numerator on the other side. And we're going to circle the denominator up to the numerator on the other side. And this is what way we're going to go. We're going to go up. So I asked myself, what's 8 times 2? That's 16. So this side is going to equal 16. 2/6 is going to be 16. What's 6 times 2? It's 12. So let's erase this. Which is bigger, 12 or 16? You would say, well, 16 is bigger, Mr. Heaver. And how do we do that? By drawing our butterfly. This works every time. Okay, and this is something we're going to practice because you got to know it next year. So if Kara also tried the rope ladder and climbed 2/4 of the way up, who climbed the highest? So now we're going to add Kara in this. Remember, Kara, she added 2. She did 2/4. So her numerator is still 2, like everyone else's. But look, her denominator is 4. It's even smaller, which means the pieces are actually going to be bigger. So now let's look at her. 2, 3, 4. Now look at hers. Now look how much she's done. She's still past everybody. So Kara will climb the highest. And we know this why? Because her denominator which is the bottom number, is smaller, which means where her denominator is smaller, which means she went further. Because remember, she's only going 4 steps. They're going 8 steps, 6 steps. I mean, that's even another way you can look at it is you're going up a ladder. This ladder has 8 steps. This one has 6 steps. This one has 4 steps. Everyone takes 2 steps. Who's closer to finishing? 2/4. Because you only got 2 more steps to go. It's closer to the hole. 2/8 needs 6 more steps. Hint, hint. 2/6 needs 4 more steps. So the less steps you need, the closer you get to finishing. The farther you are. This one says on your own. Ted walked 2/3 of a mile to his soccer game. Then he walked 1/3 of his way to his friend's house. Which distance is shorter? So soccer game, 2/3, and friends was 1/3. It says what's one shorter? They have the same denominator, which means we just look at the top number. Which is bigger, 2 or 1? 2's bigger. So what's one shorter? Friend's house. Going, because shorter means less than. So we're saying it takes longer to walk to the soccer game, which is true. It's shorter to walk to his friend's house. Going to his friend's house. Explain. We have the same denominator, but different numerators.
Principals meeting at 10 a.m. this morning to go over the re-entry of 4 days a week. Our faculty senate meeting will begin at 1 o'clock. If you have scheduled Teams meeting with your students, please reschedule that time. This is a meeting that everyone will need to attend.
All right, sorry about that. So the next one. Fury is spreading jam on 8 biscuits for breakfast. The table shows the fractions of biscuits spread on each jam flavor. Which flavor did Shiri use on most biscuits? So look, she made 8 biscuits. Every one is the same. So this is telling me on 3 out of 8 biscuits, she used peach jam. This tells me 4 out of 8 biscuits, she used raspberry jam. And this tells me 1 out of 8 biscuits, she used strawberry. So really, they're the same denominator, so we look at the numerator. What has the biggest number? 4, which means she put raspberry on most. The answer is strawberry. Well, strawberry, that always tells us. She put what jam was the least? She only put 1 out of 8, 1/8. So there's 8 biscuits, only one of them has strawberry. And that's the question it wants to know. Answer strawberry. That's what jam was the least. That's strawberry. It says, suppose Siri had also put plum jam on biscuits. She frosted 1/2 of the biscuits with plum jam or biscuits with peach jam, 1/4 with raspberry jam, 1/8 with strawberry jam, and 1/8 with plum jam. Which flavor did Siri use most on biscuits? This is going to take a minute. So we have peach, which equals 1/2. Got it? We have raspberry. I'm going to put ras, which equals 1/4. We have straw and plum, which both equal 1/8. So it says, what flavor jam did Siri use the most? Well, look, they all have the same numerator. They all have the same numerator. But the denominators are different. Remember, the bigger the denominator, the smaller it is. So we could have a model. Let's make 3 models because the last 2 are the same. This is going to be 1/2 or peach. This is going to be 1/4 or ras. And this last one's going to be straw and plum, which is 1/8. So 2 pieces. 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7, 8. So that's strawberry and peach. That's raspberry, and this, or strawberry and plum, and this is peach. What's one's closer to the finish line? It's going to be peach. That has the smallest, so there's less pieces. They're closer to being fully done. Miss Gordon has a snack bar. One recipe uses 1/3 cup oatmeal, 1/4 cup milk, and 1/2 cup sugar. What ingredient will she use the most of? Well, think about it. They all have the same numerator, but which one is closer to finishing the whole? This needs 1 to finish, this needs 2, and this needs 3. Whatever one is the closest is the most, and it's actually flour. Flour is going to be the biggest because that's a 1/2 cup. This takes 3 to make a cup. This takes 4 to make a cup. So it's going to be flour, F-L-O-U-R. And again, we will use the manipulatives at school. Next one, last one. Rick loses it, or if you need to pause it right here. Right here. Go ahead and pause it. All right. So Rick lives 4-6 miles from the school. Noah lives 3-6 miles from the school. Use fractions. They have the same denominator. So we have 3/6 and 4/6. Same denominator means it's easy. What number is bigger now? 3 or 4? Going to be 4. Same pieces. They're going to be the same size. So now we just go off which one is bigger. So 3/6 is less than 4/6. All right. So this one uses the same denominator. It should be easy, okay? Same denominator, which means look at the top number. What one's bigger? This one's different. We have 4/8 and 4/6. We can do the 2 ways. We can draw models, but that might not be equal because you got to make them equal. But let's try this, okay? We have 4/8, which represents green. Put a G above it. And we have 4/6, which represents P for purple. Let's do the butterfly real quick. So I'm gonna draw my butterfly, and the butterfly flies up. I know 8 times 4 is 32. Let me do the butterfly this way. I know 6 times 4 is 24. Now ask yourself, erase it all, ask yourself, which number is bigger, 24 or 32? Hopefully you said 32. So really, 4/6 is greater. So it says which one is less full. So which one is less than 4/8, which is the green paint jar, green paint. You need this information. I want you to do number 5, okay? Explain how whether 5/6 or 5/8 is greater. They have the same denominator, or the same numerator, but different denominators. which one is closer to the whole, all right? You only have to do 2, 4, and 5 on the front, and on the back, they have the same denominator, okay? Same denominator, so just look at the top number. We know that 3 is going to be greater than 2. Hint, hint. And the rest of it, guys, you guys should be pretty good, okay? I know this lesson might be a little difficult, but there's a bunch of strategies we're going to start utilizing, okay, to make it a little bit easier. All right, have a good one.